Today, in this video, we will see types of beams with loading and their maximum shear force and maximum bending moment. First, see simply supported beam with UDL. W per unit length. Shear force for this beam is, see, consider this distance L. WL loads acts on this L by 2 distance from this point A, and reaction at point A is WL by 2 and point B is WL by 2. That's why here shear force is WL by 2, and due to this uniformly distributed load there is inclined line to shear force, and here also WL by 2. This is positive negative WL by 2, and bending moment for this simply supported beam with uniformly distributed load is WL square by 8 and maximum at center, because this shear force is 0 at center, and where shear force is 0, bending moment is maximum at 0 shear force. Now see, due to this uniformly distributed load there is this maximum at center, and value is WL square by 8. Now next, cantilever beam with uniformly distributed load. Length of this cantilever beam is L. Shear force is, see, this is W per unit length. There is free body diagram of this cantilever beam is like this: vertical reaction, horizontal reaction, and movement. And so here, due to this vertical reaction there is shear force on this beam. This is W per unit length, that means WL shear force here, WL, and due to this uniformly distributed load there is inclined line, positive shear force. And see here, why why I write positive bending moment, because there is deflection of beam is like this, sagging bending moment, and sagging bending moment is positive. And here see, deflection of beam is like this, hogging bending moment. That's why here bending moment is negative. See here is bending moment is WL square by 2 and negative bending moment, negative WL square by 2. Now next beam is simply supported beam with point load at center. Point load W, this L by 2 distance, and this is also L by 2 distance. So here shear force is W load acting on this beam. So here reaction is W by 2, equal reaction W by 2. Every action there is equal and opposite reaction. So this W load is action and their reaction is this. At point A vertical and at point B there is vertical reaction. Every action there is equal and opposite reaction. So due to this W by 2 there is vertical shear force W by 2, and up to this L by 2 distance from A there is not any force acting on this L by 2 distance, so there is straight line, and due to this W there is change in shear force. So here W by 2 is positive, negative, W by 2, W by 2. Okay, and deflection of this beam is like this, sagging bending moment. So bending moment here is positive bending moment, and here there is not any uniformly distributed load. So here straight line comes, and bending moment is maximum at center, positive, and maximum bending moment is WL by 4. See, at this point, L by 2 point, calculate bending moment. See, this W by 2, consider this clockwise movement positive and anti-clockwise movement negative. WL by 2 into positive W by 2 into this perpendicular distance, that means lever arm L by 2, and at this point, see, this P point force goes through this point like clockwise, that's why here positive, and here this W goes through this point, that's why lever arm 0, so not any bending moment act on this point, equal to 0, therefore WL by 4. So like that way this bending moment calculated. Next beam is simply supported beam with point load acting at eccentric. See here diagram, in diagram. Simply supported beam with reaction at A and reaction at B, and this W load act at a distance small a from capital A and at a distance small b from capital B. Now reaction to this at point A is WB by, and total length of this beam is L. WB by L, and at point B is WA by L. So here shear force is, see, WB by L vertical, force is vertical, so vertical shear force here W, there is this plus WB by L minus W, there is downward shear force, and here WA by L, positive, negative, here WB by L, and here WA by L. These reactions are acting on shear force. This reaction is nothing but the shear forces. Okay. This beam is also deflect like downward, sagging bending moment. So bending moment is positive bending moment, and here bending moment is WAB by L. Calculate bending moment at this point. Clockwise movement is positive. Positive WP by L multiply by A. Therefore, WAB by L. Okay. Now next is fixed beam with uniformly distributed load. Fixed beam with uniformly distributed load. See, this beam is statically indeterminate beam. Why statically indeterminate beam? Because see here reaction and movement. See here vertical reaction, horizontal reaction and movement. There are 6 reactions. And our equilibrium equation, summation of fx is equal to 0, summation of fy is equal to 0 and summation of moment is equal to 0 are 3. That means 6 minus 3 equal to 3. 3 degree of statically indeterminate equation. And for that, here shear force is, see, WL by 2. And here also WL by 2. And here see, in this beam there is deflection like this deflection. That means here at the center of the beam there is sagging bending moment, and at the support of the beam there is hogging bending moment. So here bending moment diagram comes like this way, and due to uniformly distributed load there is, see, like this sagging bending moment is, so here see negative side and this is positive side. Sagging bending moment is positive and hogging bending moment is negative. Sagging bending moment is WL square by 24 and hogging bending moment is WL square by 12. Next beam is also fixed beam but point load. Fixed beam with point load W. This is A, this is B. Here and at the distance L by 2 from A and L by 2 from B. Here W by 2 and movement is straight line, not curved line. This is straight line because there is not any UDL acting on this beam. So straight line. This is negative hogging bending moment. This is positive sagging bending moment. WL by 8 and WL by 8. And here also WL by 8, positive, negative. So Simply supported beam with uniformly distributed load, shear force is WL by 2 and bending moment is WL square by 8. Cantilever beam with uniformly distributed load, shear force is WL and bending moment is WL square by 2. This is maximum shear force is WL and maximum bending moment is WL square by 2. For simply supported beam with UDL, maximum shear force is WL by 2 and maximum shear force is WL square by 8. Simply supported beam with point load acting at center, maximum shear force is W by 2, maximum moment is WL by 4. Simply supported beam with point load W acting from distance A and the distance is small a, maximum bending moment is C WB by L and maximum shear force is WAB by L. Fixed beam, fixed beam with W load per unit length, uniformly distributed load, maximum shear force is WL by 2 and maximum bending moment is C WL square. Maximum bending moment, that means hogging bending moment is WL square by 12. Hogging bending moment is maximum in this case between WL square by 24 and WL square by 12. Here 12 denominator is small, that means value of hogging bending moment is maximum here. Here fixed beam with point load W acting at a center, bending moment is hogging bending moment and sagging bending moment value is similar but signs are different. Shear force is W by 2. Thank you very much.